Okay, so we're going to work on this a little bit more, subtracting. This time we kind of did, this will be 8.5 part 2. We worked on adding with unlike denominators, so this time let's subtract rational functions, or rational expressions, I should say, with unlike denominators. And we're also going to learn how to simplify what we call complex fractions. Alright, so let's look at another example here. We're going to subtract these rational functions. Okay, so they don't have like denominators. We're going to have to get a common denominator. So the first thing we're going to do is factor the denominators. We have to get them factored so we can look at them and see what the common denominator would have to be. Okay, so on this first denominator I can factor out a 3. And that would give me 3 times x minus 3. Remember, distributive property backwards. Okay, now here we've got the difference of two perfect squares, so we can factor it with our a plus b and our a minus b. Okay, so now let's decide what our common denominator would be. We know we need both of these terms, and the x minus 3 would be in both, and then we also need this 3. We need a representation of every single term to get a common denominator. So I'm going to have the 3, and then times x plus 3 times x minus 3 would be my common denominator. So I'm going to spread this out again so we can see what's missing here. Alright, so this one is missing the x plus 3. So I'm going to multiply by the x plus 3. This one is only missing the 3. So top and bottom. Okay, so if I multiply all of this, and then I'm just going to write this 3 in front. So I'll make sure I do. And then I'll have my common denominator here. Okay, now we just need to clean it up. Let's do the distributive property on both of them. And one more step, combine like terms. 7x minus 3x would give me 4x, and then the 21 minus 12 would give me 9. And again, you don't have to multiply out the denominator, just leave it factored. Okay, alright, so now we need to work on simplifying complex fractions. Now, complex fractions are when you have a fraction over another fraction. So you have a fraction here divided by another fraction. Now, in this denominator, we can just treat this like a separate problem, and we already have a common denominator. So let's just add those two fractions together. I would get x, and then 1 plus 4 would give me plus 5 over 15. Okay, so we cleaned up this denominator. Now, remember when you divide fractions, you change it to multiplying by the reciprocal. So I'm going to flip the second one and multiply. Okay, multiplying by the reciprocal. Might look kind of weird, but I wrote it like that because I can reduce these two fractions here. And 5 goes into 15 3 times, and then I'll just have 8 times 3. Okay, one more step. Okay, let's look at one more example of this. These look really crazy complicated, but they're not that bad if you just try not to let them intimidate you. Okay, now you can treat this as a separate problem and get the common denominator like we've been doing. And then you can do what I did up here and multiply by the reciprocal. But I'm going to show you another technique that makes it a little bit easier. I'm going to think about what the common denominator is. So I know I have an x plus 1. And then I also need to multiply it by this 3x. Okay, so 3x times x plus 1 would be my common denominator. Now, if you multiply by this common denominator, and I'm going to write it in a strange way, I'm really just multiplying by the number 1 here, but I wrote it like this. It's going to help me clear out all the fractions. So I'm going to multiply across, and I'm going to do it in the numerator and the denominator. Okay, multiplying across here. Now I'm going to have 3x times x plus 1 times 1. And then that'll be over 3x plus, now I have to multiply it times this one too. 2 times 3x times x plus 1 all over x plus 1. I know it looks crazy, but now we're going to clean it up. This is just the number 1, so they reduce out. And I get 2x times 3x, which would be 6x squared. Okay, these 3x reduce out. That's just the number 1. These x plus 1s reduce out. So I have x plus 1 plus 2 times 3x would be 6x. So that turned out not to be so bad after all. X plus 6x would give me 7x plus 1. Alright. You might need some extra help with this section. It's the hardest section. So please come to RTI and please come to class with questions so we can work on this.